Okay, welcome Year 12s to this video. In it, I'm going to be running through the Module 1 matrices of the trial exam that you completed. I'll try and make it as clear as possible a strategy to answer each question, particularly those that are more difficult. And then I'll just describe to you how the answer is achieved from some of the others. So first of all, we start off with this question about some residents competing in some different sports, and those residents are male or female. That's shown in the matrix, and we've also got that they're from two different towns, G and H. Okay, so to start off with, we're interpreting a matrix. How many athletes are residents of Haldor? If we have a look here, we've got one male and we've got one female, so there are two residents altogether. Hopefully we were all able to answer that question. With this next one, it was a little bit more challenging. Each of the 6 athletes are competing in one of 3 events. So we've got table tennis, running, or basketball. And you'll notice we've got the table tennis and we've got the running matrices. What we want to complete is the basketball matrix. Now, it says matrices T and R shown. We've got that there. It's got the number of female and male athletes from each town. Now, what we also know are those totals. Now, that's going to be really important up here. We know how many males and females there should be altogether from each of those towns. We're going to have to use that to help us fill in the matrix, because if they're not doing table tennis and they're not doing running, it means that they must be doing basketball. So if we have a look at the total number we want for males from Gillen, we need 2 males from Gillen altogether. At the moment, we've got none in table tennis. We've got 1 in running, which means we need to have 1 to make up for that other person that's doing basketball. If we have a look up here for the females, we've got 2 of them. And if you have a look here, 1's doing table tennis, 1's doing running. So we can't have any of them doing basketball because we've already got 2 accounted for just here. And we'll finish that off. There is 1 male from H. And we've got that male accounted for here. So we'll have a 0. And finally, for the females from H, I've got none in table tennis, none in running. So that female needs to be here. So that's how we get that matrix, our answer for part B. Over the page now, we're given then, there we go. We're given this matrix C, and that's the cost of the uniforms for each of those events. Now you'll see for which event will the total cost for the athletes be $1,030. Now if I have a look at my matrix here, I can see the cost obviously for each event. And so what I'm asking, or what it's asking me here, is for which ones will I multiply by a certain number to give me 1,030? So if you have a look at our matrix before, you'll notice that really the maximum that we have for each of the sports is 2 people. We've got 2 people in table tennis, 2 people in running, and we've got 2 people in basketball. So really it's asking, when I multiply one of these by 2, which one of them is going to give me 1,030? And so you can see the only one is going to be this one. Since 2 by 515 gives me 1,030. And that sport there is table tennis. So the next thing we want to do is write a calculation that includes matrix C. So it's got to have this one in it, and I might actually just write that out to start off with. It's got to have this matrix in it. And then it also says to show the total cost that you've done here for table tennis is contained in the answer of 1,030. So we want some sort of calculation here that's going to give us this answer, 1,030. As you can see, for this to happen, I can't use matrix addition or scalar multiplication because this matrix C is not the same order as this matrix, a 1 by 1. So it means, or it highlights to me, I need to use multiplication. And the reason that I've put this matrix C second is you'll notice this is a column matrix. So this is the dive in the calculation. That means over here I need to have a run. Now, a run with one column would mean I've got one row. So I'm going to do one run, one dive that will give me one element over here. Now, all I want is this 515 to be multiplied by 2. I don't want anything else to be added on. So I'll put zeros in these other two elements to make sure that the 550 and the 580 effectively are going to be cancelled out. And so this will be your answer. Now, part D was a little bit more challenging, and you'll notice that there's this space at the bottom. So do use that space if you need it. I'm going to do that, as you can see, in a moment. So just first of all, we've got to use matrix C here, which was given above. And then matrix Q is what we're trying to establish. So we're also told what is contained in matrix V. So that's in this little bit here that they've asked us to use. And so what I'm going to do in that space below is start to set up matrix Q. I'm going to write matrix C next to it so I can actually see what's being multiplied. And then beside that, I'm going to have matrix V. So, so what is it that I want in each of those elements? Okay, so as you can see, we've got V equals Q times C. So I'm going to write, so what is Q? Now I've got pieces of it here, but I like to have it written directly beside it. Actually, what might help is me doing it just here. That might be a better idea. Okay, so I've got my 515. This is matrix C. So that's Q multiplied by C, which is what I had up here, Q by C. And then in this one, this is V, because this is what it has to equal to. I'm going to make a note, excuse me, of what I should be getting in here, just to make things easier. So notice here I've got total cost of uniforms for female athletes from Gillen. So all of these are total cost of uniforms, but what I want in this one is females from Gillen, so I might just use FG. Then I want females from Haldor. Then I want, male from Gillen. And in this one, males from H. So what you can see here is I've got down the side here, table tennis. What was the second one? I've forgotten. Was for running, and B was for basketball. So when this multiplies, I'm going to have a run and a dive, and that's going to give me females from Gillen. So what I'll do is make sure that in this matrix, I've got the events in the right order. So see how the run and the dive is going to match. Table tennis needs to match with table tennis, running needs to match with running, and basketball needs to match with basketball. So it should be, these labels of course could go at the top, but I've just put them at the bottom for space. So if we have a look here, if we want the females from Gillen, we want to have a look then at what sports are they in. So just going back to these matrices from before, females from Gillen, I've got one in table tennis, I've got one in running, and I've got none in basketball. So that's what this is going to have here. This is going to be the females from Gillen. This has got to be the females from Haldor. This has got to be males, etc. Because what we want is these values to multiply by the uniform costs and obviously add together. And then those elements are going to be shown in V just over here. So I had for females in Gillen, one in table tennis, one in running, and I had none in basketball. Now, if you have a look at your next one, FH, so females from Haldor, we'll just go over the back here. Females from Haldor, we had none, and then one. So here, none, here, none, and here, 1. And that's what we see here as well, 0, 0, and then 1. So you notice it's there to help you, if you are stuck, to help you piece together what's happening here. Once we've established it, we can then, it's just a case of reading off the males from Haldor at this point. So if we go over males, Haldor, we've got 1, we've got 0, and we've got 0. So we'll fill that in now. 1, 0, and 0. Okay, so there's our answer for part D. Like I said, it was a little bit challenging to interpret what was going on here. So my best strategy for you is to jot down, like I've done, what actually were we given and what did we need. So then we could establish what needed to be multiplied in this matrix by those total costs just over there. Okay, moving on now to the next question. We've got this massive transition matrix here. So my first suggestion for you would be, after reading the question obviously, would be to get that matrix into your calculator because we are going to be using it further down here. So I've done that already. I'll use it shortly. The next thing that we've got is a state matrix. So it's all to do with residents watching different channels. And that too I would also store into my calculator. The first part is to get us to understand how is this transition matrix working. In other words, what calculation would need to be done to get the no television at 10 o'clock. So in other words, this is G0, which is 9 a.m. So 10 a.m. is going to be G1. So the very next transition from this first one. Now we want no TV. So in other words, we want to be looking at this row here. This row here is showing us which or what percentages from each of the channels for the next hour moving across or transitioning across to no TV. And so if we have a look at that, it's going to be 0.15 of C1's value. So in other words, 0.15 of 100. It's going to be then a quarter, or 0.25 of C2's value. So 0.25 by 400, you'll notice that's already there. It's then going to be 20% or 0.2 of C3's value, which is 100. And then it's going to be 0.5 or half of the no TV value, which is 1400. And of course, we could do that calculation if we wish. If you've got that in your calculator, the T and the G. So I'll show you now. I've got T stored. I've got G stored as well. And transitioning T times G, you'll see I get that final value of 835. So just demonstrating how that value is obtained. Just delete that for a moment. Okay, we're next asked to determine number of residents expected to watch C3, so the third element down, at 11 a.m. So if this is 9 a.m., we're clearly looking for G3 in this case. Oh, sorry, G2, since this is G0, like so. So it's the third one across, which relates to G2. So I'm finding G2, I need to do T squared, or T to the power of 2, multiplied by G0. And so that's what I'll do in my calculator now. And then I need to just make sure I state just the element on C3. Okay, so T squared, and I want to times that by G0, which I stored earlier. And then we have 400, 584, 356, and 660. $356 and $660. And then, of course, we state the final answer. We only want this one. So 356 residents is our final answer. We just make sure that we're nice and clear what our final answer is. We don't just leave it in that matrix, because then, of course, we're actually giving 4 answers, not one of them, as required. Okay, so if we continue across now to question 3, this one is definitely the harder, probably the hardest in my opinion out of all of the questions in this module. There's a lot of reading here, but secondly, just in terms of what you need to do, it's a bit of problem solving. So we've got these basketball finals and they are going to be televised. So 12 noon till 4, we're given a time. And we're also told expected that there's 600 residents watching C3 at any time. And we've also got the remaining residents not watching, from 12 till 4, and that's at any time. So what that means is if we looked at any of the G values, so any of those state matrices, we should see the same values coming up, the 600 and the 1400, for whether they're watching or whether they're not watching. So if we consider then what we've been given, there's only 2 elements. We've got, are they watching C3 or are they not watching C3? Now, we were told that 600 of them will be and 1400 of them will not be. So here's really a state matrix that we can be using, a new state matrix. Now, we're also given this transition matrix that we want to use to generate what's happening here. So in other words, if I take this transition matrix, so V, W, we've got the 0.35 and we've got X, and I multiply that by these original values that I was given, I should actually get the same values again. So there are going to be transitions taking place, but the way that those transitions are taking place actually leads us to having this exact same values as we started with, because at any time between the 12 noon and the 4, we're transitioning, but we're still seeing the same constant values who are watching and who are not watching. So to start off with, since there are no new residents coming into this system, so we've got 2,000 residents altogether, there's no one new sort of turning on, what I should see is this V value should be the complement to the 0.35. In other words, this should still add up to 1. So that means that this value should be 0.65. Now that's just from our knowledge of transition matrices, having the columns add up to 1. So even if you were completely stuck, hopefully you were able just to get that bit. So just to get at least one of these values. So just put that in here, 0.65. The next part is a little bit more challenging, but not if you understand that this calculation here, to get this value over here, we would be doing a run and a dive. So if you have a look over here, I know that this bit, the run, will dive down here and it's going to give me these values over here. So what I'm going to do is demonstrate that if I do this run and dive just by hand, so 0.35 by 600 plus this X times 1400, I have to get 1400. So this second run and dive gives me this element right here. Now what you can do from there is you can actually use this in your solve, so you solve, to work out what X is. So type that into your solve, and what you should find is X is 0.85. And once I establish that that's 0.85, I then know what W is because they need to add up to 1. So that has to be 0.15. So as you can see, a question like this, there have been some that you've come across previously that I've helped you with or some girls have asked for help with stuff from the chapters where they've found that this was necessary. So when there's something missing in a matrix like this with transition matrices, see if there is a run and a dive that you can set up and you can solve. And then on to this last question. Now, luckily for us, this transition matrix is the exact same one that we've used previously. So you can check that if you like, but I had a quick look before and it is the same one, which is great because you've already got that stored in your calculator, so that will save some time. Again, it is very wordy, so it's going to take you some time to read the question, perhaps highlight things, important information. For example, that 50 tourists are arriving every hour. That's very important. But also this bit here about the 80% watching only C2 and the 20% not watching television at all. Because that information there indicates that not just we don't just have transitions taking place, which is shown here in the recurrence relation, but we also have more people arriving. And that's actually what we need to find in part A. We need to find this matrix V that's going to be added on, and that information is contained in that paragraph above. So what's going to happen, and we're going to try and find V, is we're going to have 4 elements because we've got 4 different things happening here. We've got C1, we've got C2, C3, and the no TV. Now what matrix V is doing is adding those people into the system. So if we have a look up here, just to get a couple of values in to start off with, these people who are arriving, 80% of them are going to either C2 or to no TV, which means that none of them are going to C1. So nothing will be added on to that, and nothing will be added on to C3 either. So we'll put zeros there. What we want to know is how many of these 50, remember 50 were arriving, how many of the 50 are going to C2 and how many of the 50 are going to no TV? If we look at C2, we've got 80% of the arriving are going there. So 80% of 50. So what you need to first establish is what 80% of 50 is, which is 40. And then, of course, the rest are going down here. So that's going to be 20% of 50, which is 10. Or we know 40 are up here and there's only 10 more people. So we've got 10 people who need to be added to the no TV section. So there's our matrix V. Now, since we're then asked to find for 7 o'clock, we then want to make sure matrix V is in our calculator because 7 o'clock is going to be a couple of transitions. So notice here that 5 o'clock is what's shown here. So 5 o'clock is this one. So we need to do 2 transitions. So W1 is going to be 6 o'clock and W2 is going to be 7. All right, so what we first want to find is W1. Now remember the recurrence relation is here. This is what we have to do. We have to do T times W and then add on V. So if I just have a look, I know I've got T stored. I've stored W as well, and I've also stored V. There it is there. So I want to do T times W, and then I want to add on V. So there's my value for W1, but I don't want W1. That was for 6 o'clock. I want for 7 o'clock. So I need to transition again. So now I'll do T, times, sorry if you can hear my cat purring. Very awkward. She's sitting right on me. T times this one, and then I'm going to add V again, add V. There we go. So I've transitioned my answer, because remember you have to do that, you have to use recursion, transition the answer, and then added V, and then we have our final matrix W2. Okay, so if I do W2 now, we're then going to establish what is our actual answer to this question, because it didn't ask for W2, it asked for C2. So W1 is T by W0 plus V. I did that in the calculator. That gave me 400, 640, 380, and 630. Now notice this is worth 2 marks, so making sure I demonstrate all of my workings here. Whoops, I went too far. Okay, and then my next one, T by W1 plus V, and that's giving me 396, 666, 417, and 621. And our answer was for C2, so I am now just listing my final answer over here outside of that matrix. So apart from the fact my writing's very messy here, do make sure that you do show your workings, particularly anything that's worth 2 marks, because I suspect here what might have happened is they, since this part was required, there may have been some consequential marks available here. So if you didn't show workings, you might have then lost all 3 marks. So very important, particularly with the 2 mark questions, to make sure you're showing your workings. Okay, I'll stop there.